Hello guys, we are meeting once again. We have our question for power machines N5. The topic is gas processes or chapter 1. So it reads 100 kilojoules of heat is used to raise the temperature of a certain gas from initial temperature of 288 Kelvin, our volume V1 0.5 to a temperature of 350 Kelvin at constant pressure. The specific heat capacity, which is our CP and our CV, are given as 1 kilojoules and 0.7 kilojoules per kg Kelvin. Now, on this question, they want us to calculate the mass of the gas. So you can see first thing that we need to do, let's write our data. We have our energy, which is our given as 100 kilojoules. We have our T1, which is 288 Kelvin. We have our 350, which is our T2. So we are given, and then we also have our CP, which is given as 1 kilojoules, and our CV is given as 0.707 kilojoules per kg Kelvin. Yeah, so our T2 is 350 Kelvin, and we also have our initial volume, which is given as 0.5 cubic meters. So this is what we are given. So the first question, they are saying we must calculate the mass of the gas. So we can use our formula P1 V1 equals 2 mRT. Now, this formula was going to be fine, but we have a small problem. We are not given our P1. So since our P1 is not given, but we are given our energy, we can use that formula for energy. Remember, this is an isobaric process. Isobaric process, it says energy equals to mCp into T2 minus T1. That's our formula for calculating our energy if it's our isobaric process. Therefore, our energy is given as 100 kilojoules. Remember, we're looking for our mass. So we write our M times our CP, which is 1, times our T2 is given as 350, minus our T1, which is 288 Kelvin. So if you make our M subject of the formula, let me get my calculator. So if we substitute there, we make our T2 subject of the formula, rather our M subject of the formula. We are going to have, it's 100 divided by 1 times 350 minus 288. So we are getting 1.613 kgs. So that becomes our 2.1. That's our mass. On question 2.2, they want us to calculate the gas constant. So for gas constant, we can use many formulas, but unfortunately, we can't use this one because still we don't have our P1. So the easier formula to use, we can use R equals to CP minus our CV. Since we have our CP and our CV. Our CP, we say it is given as 1, and then our CV is 0.707. So the difference of the two gives us our gas constant. So it's 1 minus 0.707. I'm getting 0.293 kilojoules per kg Kelvin. So that becomes our value of our gas constant. And then 2.3, on question 2.3, they want us to calculate our original pressure. So because we have our V1, we have our mass, we have our gas constant, we have our T1. It now becomes easier for us to get our initial pressure. So we can now say if P1 V1 equals to mRT1, our P1, we are looking for P1, our V1 is given as 0.5, our mass We just got it as 1.613, our gas constant 0.293. Our T1 is given as 288. So from there, we make our P1 subject of the formula, which becomes 1.613 times 0.293 times 288. We divide by our 0.5. So let's see what we are going to get. 1.613 times 0.293 times 288 over 0.5. We are getting something like 272.223 kilopascal. So don't forget, it's an isobaric process. So which is to say the value of our P1 is equal to our P2. So in this context, P1 is equal to 272.223. Same applies to our P2. So the pressure is constant. So we are done on 2.3. Let's reflect on 2.4, the value of, or rather the volume at the end of the isobaric process. So they are referring to V2. So I can write my 2.4 here. 2.4 here. So we have our formula P2 V2 equals to MRT2. I think this becomes a simple formula. We are looking for our V2 because we have our P2. Remember, it's an isobaric process. So P2 is equal to P1. And then our mass, we have it. Our gas constant, we have it. Our T2, we have it. So we substitute 272.223 times our V2 equals to 1.613 times 0.293 times our T2, which is 350 Kelvin. So making V2 here subject of the formula we have, it becomes 1.613 times 0.293 times 350, all divided by 272.223. So let's get our value of our V2, 1.613 times 0.293 times 350, all divided by 272.223. We are getting our V2 as 0.609 meter cubed. So that's what we are getting as our volume. That's what we are getting as our volume. And then let's go to question 2.5. On 2.5, they want us to calculate our work done. Remember, it's an isobaric process. So formula for work done, we use work done during isobaric process is equal to MR into T2 minus our T1. Our mass 1.613, our gas constant 0.293 into our T2 is 350 minus T1, 288. So let's substitute to see what are we getting there. We have 1.613 times 0.293 times 350 minus 288. It gives us 29.302 kilojoules. That becomes our work done. And then 2.6, they want us to calculate our change in internal energy. Change in internal energy, that's our delta U. Delta U equals to M CV into T2 minus our T1. Our mass 1.613 times our CV. It was given here as 0.707 into our T2 is 350 minus 288. So let's substitute. We see what are we getting there. Let's substitute, we see what we are getting there. 1.613 times 0.707 times 350 minus 288. I'm getting something like 70.704 kilojoules. That's our change of internal energy or change in internal energy. Lastly, on 2.7, they want us to calculate our change in entropy. So change in entropy is the same thing as our change of entropy. Now, we can use a number of formulas, but the easier one to use is delta S equals to mCV into ln of T2 over T1 plus our V2 over our V1. Yeah, so it's rather ln V2 over our V1. So this is our formula which you can use. We can use this one, but we have many formulas for changing entropy. But you must always be careful when you're using a formula. Understand that in this part we don't need to include our pressure, because already, since it's an isobaric process, our pressure is already what? A constant. So let's substitute our values here. Our mass 1.613, CV 0.707 bracket a ln of T2, which is 350 over ln of 288 plus V2, rather plus ln of V2, which is V2, we got our V2 as 0.609 over ln V1, we got, it was given as 0.5. So let's substitute to see what are we getting there. 1.613 times 0.707 ln of 350 divided by 288 plus ln 0.609 divided by 0.5. We close our bracket. I'm getting something like 0.316. 0.316 kilojoules. So that becomes our change in entropy. So that's how our question is supposed to be solved. But don't forget, when you are dealing with such a question like this, understand the process that you are dealing with. This is an isobaric process. Always remember, an isobaric process is conducted in such a manner that the temperature remains the same throughout the process. So that's an isobaric process. Let's meet again on the next question. Thank you.